Let's talk about bread. It's a very interesting food, and when it is heated, it undergoes a number of chemical changes. As the proteins break down, the flavor changes, the outside of the bread gets caramelized, and it's really interesting as a chemist because oftentimes we might want to track those changes, and with a device like this, a portable near-infrared spectrometer, we do that pretty easily. Now, these changes all can overlap, and thus the data can be somewhat complex. But we would like to think that as we toast the bread, we go from white bread to toasted white bread, that we might be able to understand these chemical changes and perhaps tell some story about that process through the near IR data. And so that's what I want to do. I want to take this white bread and toast it. Now, interestingly, I had this idea and I don't have a toaster, so instead I actually used an air fryer. In fact, that's how we do most of our toasting and cooking, but I digress. So what I really want to focus on in this case is likely to be the moisture losses. That will likely be a very easy measurement that we can use and understand, although I want to remind you that there are a lot of other chemical changes that will be occurring as this bread is toasted. So likely some signals going up, some signals going down from the start to the end of this process. But let's get started. Now, I want to begin with looking at the raw data. Oftentimes I jump right into the Python, but I think there's something to understanding where we're starting with the experiment. And so I want to walk through that first, and then we'll jump into our Python notebook. What I'm showing you now is the raw data that I've entered into Excel. This was imported from the website where this data is being hosted. And you can see in this measurement description column, we have all the data from 10 minutes to a 9-minute QC run. This is actually a piece of reference bread that I was storing on the side that was not toasted. It was just exposed to the ambient conditions. And then a 9-minute toast, 8-minute toast, 7 minutes, 6 minutes, a 6-minute QC sample. So the same piece of bread, but at 6 minutes, 5, 4, a 4-minute QC, all the way down to 0 minutes. And as you can see that there is a lot of other data over the course of this run, many different wavelengths as you can see across the top, and then down in each row, we have an absorbance value as we continue to measure the bread. So for this measurement, I was simply taking the probe and sampling different parts of the bread. Some parts are more toasted, some parts are less toasted. I would try to at least get 4 or 5 scans at each time point. And then using Python, I would average each of those time points and then visualize those results. So let's do that. So now, what is really nice to do is that instead of trying to do all this analysis in Excel, where we now need to separate the time data from our QC data, we need to clean this up. And this is certainly something that could be done with a set of Excel commands. I would rather use Python for this sort of analysis, as it is more transparent. It's a little bit easier for me to track what's going on and to be able to tell a compelling story from this data. And so to begin, we're going to import a number of libraries to help us perform this analysis: Pandas, Matplotlib, Seaborn, warnings just to help us as these libraries are updated, and then plotly.io depending on how we want to visualize. And then I'm just going to set some of my Seaborn styling up in the front of this, as well as just ignoring some of the warnings that will occur in this notebook. Then I will next load in this data. Let me know if you want this data. I can upload this to the GitHub repository where I've stored other near-IR data if you want to perform this analysis or perhaps study some of the other changes that are known to occur within bread. And what I want to do now is filter the data so that we can now exclude the QC samples. I don't want to incorporate that into this part of the visualization. I will perhaps do another study where we look at this. And I think it's going to show us something pretty interesting as we look at the bread over time that has not been toasted. So again, this is a reference piece that allows us to understand perhaps if there are any changes with the probe, changes with the bread that are not due to the toasting, but rather just being left out in ambient conditions. And then we're going to create that mask and then filter our data to remove those QC samples and then select just the analytical data. So we're going to ignore all the columns that are at the beginning of this data table, the spectrum ID, the method development, the device ID. Those things are not important for this part of the analysis. So we're just going to filter that away. And then we're going to create a new variable called time data, and we're going to generate that from splitting our measurement description column and converting that to an integer data type. And so in this case, we're going to separate 10 from men's based on this white space, and then 9, 8, 7, and then convert those remaining values into integers and create this time data there. So let me run these cells, and then I'll show you what time data looks like. And pretty easy, you can see that for each spectrum ID, we just have our different times. And this just allows us to have an integer for more easily visualizing this data. Next, we're going to transform this data using our standard normal variate. So oftentimes with these spectroscopic techniques, we will get different types of scattering, and that is to be expected. It is just a common phenomenon, particularly as we start to change some of the particle size. We know we're changing the surface of the bread. We know that we're going to go from a bread that is a lighter color to a darker color. We know that the actual surface porosity is going to change it. So we really want to make sure we address any scattering that's going to be due to that and help us to see some of the other chemical changes that are going to be measured by the NIR. And so standard normal variate is a fantastic way to do this. And it just sets the mean of each of our data to 0 and allowing us to look for some of the other changes that are not due to scattering. Let's run that cell, and we now have our mean centered data, and we have everything we would like here. Now, what I want to do, I have not added my time data to this data frame yet. And that's what we're going to do here when we do our data visualization. So next step would be taking this data frame, SNV NIR data, and grouping by our time data, and then averaging each of those groups, transposing that, and then creating our grouped data frame. When we see this, I want to show you what that looks like. We now have this data table here where we have our wavelengths on the index, and then we have our time on the column index values here. And so this will make visualizing the data that much easier and a great way to begin setting up for the next part of this video. Next, I'm going to plot this data in a very simplistic way, but it will be really good for telling the story of the change in the bread from the start of the experiment to the end of the experiment. And so we're going to create a subplot. We're going to set the size and then set the color map to cool warm. This makes sense because at the beginning we want a cooler color, and then towards the end, as we're toasting, it'll be a nice gradient into the warmer color temperatures, which would be consistent with the direction of the experiment and just adds to the story. And so here is our NIR spectrum from the untoasted bread at time 0 down to the toasted bread at time 10 minutes. And you can see that we have this peak here around 1900 nanometers that's decreasing, very likely peaks that could be associated with water or moisture that will likely be going down over the course of the experiment. But we also see we have the formation of some peaks in the 1600 to 1800 range that are increasing over the course of the experiment, going from this blue to red and just other patterns throughout. And so this is a really cool way where we can begin to see how complex these transformations are over the course of the experiment using a portable NIR device. And like I said earlier, we know there's lots of processes that are changing as the bread undergoes the toasting and heating process. But I want to show you another way that we can tell this story visually using Python. So next, I want to show what I would consider an enhanced visualization. And to do that, I'm going to incorporate another image. So in my images folder, I have an image of some white bread that I have background subtracted. And so this is just the white bread. And I also have an image of toasted bread. So these are two images that I took with my phone, and they removed the background. And I want to incorporate that into my visualization. And so I have a path to my white bread and a path to my toasted bread that I'm using here. And then I want to create a similar figure, but I want to modify it slightly. I want to remove some of these filler lines and just keep the two extremes. So the 0-minute and the 10-minute line. And then I want to include the image of the bread. Just want to show you what we can do with Python. And to do that, I'm going to use the plt.image show, or this im show, where I have my white and toasted bread in these two lines respectively. And then I'm going to use this extent argument to set the bounding box for the respective images. That's the first images are the wavelengths, and these are the intensity values. This process definitely took some trial and error to get the image in the right spot, but definitely worth it. And then I'm going to set two line plots, one for the white bread here, another for the toasted bread. And then we're going to label the plot accordingly. When we run this, you see the figure we get here is a really cool figure. It includes a visual hint as to what the blue and red lines are telling us. This blue line is the untoasted white bread, and the red line is the toasted bread shown here. And even without all of the lines in between, there are clearly trends that are visible based on just this more simplistic view of the data. Thus, from here, there are several other things we could do to explore this data. If you want this data, let me know in the comments and I will add a link to the GitHub repo where this data can be found. And let me know what you would do with this data. We could build a regression. We can look at changes in other types of bread, such as wheat bread, multigrain bread, or perhaps, as someone told me in one of my videos, this is not real bread. So what happens if we actually make our own bread? Will we see some of these same changes? What if we were to compare different types of bread and those transformation processes? In any case, if you enjoyed the video, like, comment, subscribe, and I'll see you in the next one.